In this video, we are going to see silicon controlled rectifier. Simply, we will call it as SCR, the working principle of SCR, and characteristics of SCR we will see. So, initially, SCR meaning that a silicon controlled rectifier, which is one of the most important member in the thyristor family. We have the two sets of family. First one is the thyristor family, and another one is called a transistor family. So first we will see the thyristor family. In this, the basic device is a silicon control rectifier. So SCR is a 4-layer 3-junction device. So if you see here, we have 4 layers PN, PN, and we have 3 junctions J1, J2 and J3. And we have the 3 terminals, anode, cathode and gate. 3 terminals are there. So this is a circuit symbol of SCR, 3 terminals, anode and cathode and gate. So here this SCR may be under two forms, NP-NP combination or PN-PN combination. So mostly we will focus on in this course is a PN-PN configuration of SCR, which is having 3 junctions J1, J2, J3. Here as noted here. Now here again anode is called a positive electrode and the cathode is called a negative electrode, and the gate is a control terminal. We have the gate terminal, that is a control terminal that will say whether the device has to be on or off. That is called control terminal. The SCR working principle can be explained under 3 modes. First one is called forward blocking mode, forward conduction mode, second one, and the third one is called a reverse blocking mode. So we will see the graph of particular modes separately. So here we have the forward blocking mode. As we can say, this terminal is called anode and this terminal is called the cathode, and the gate terminal is kept as open. There is no supply control is given to the gate terminal. When we give the positive supply, that is a positive supply to the anode, negative supply to the cathode, it is meaning that it is a forward biased. It is meaning that it is a forward biased one. Now here this positive is connected to the P layer and this negative is connected to the N layer of junction J1. So therefore junction J1 is the forward terminal. Junction J1 is the forward terminal. Similarly, junction J3, there also we have PN. This positive terminal is directly connected to this P layer, and the negative layer is connected to the N layer. So therefore junction J3 is also forward biased. Whereas when you come to this junction J3, where we have the NP combination, N is connected to the positive terminal, that is called a negative biased, and P is connected to the negative terminal, that is called a reverse bias. So therefore J1 and J3 is called a forward bias, and the J2 is a reverse bias. J2 is called a reverse bias, and the J1, J2 is a forward bias. So this is a case for forward blocking mode. So at that time there is no current flow. From this terminals from anode to cathode. There is no current flow. There will be a small amount of current is flowing, and that current we will call as we will be called as a leakage current. So that time there is no conduction takes place. So when we come to when we see the graph of a forward conduction mode, so when we keep on increasing this voltage, that time this junction J1 and J2 are forward bias, J3 is a reverse bias. When we increase the voltage beyond the breakover voltage, there will be a tremendous amount of current is flowing through this junction J2 is getting breakdown. There will be a tremendous amount of current is flowing. So till that there is a small amount of current. When we take a current as the x-axis and anode cathode voltage as current is y-axis, and anode cathode voltage is in x-axis. When we keep on increasing this voltage, there will be small amount of current. Called a leakage current at one particular voltage called a breakover voltage. breakover voltage, we will call it as breakover. The current is starts increasing, the graph is like this, so here when the current starts increasing, that time the voltage becomes very less, so that voltage we will see later. So there will be some more particular voltage where the current starts flow, the junction J2 is getting breakdown, there will be a current flow starts, so that voltage we will be called as a breakover voltage, forward breakover voltage. And the second one is called, so this mode is we can call it as forward conduction. When it reaches the breakover voltage, there will be a current flow, that mode we will call it as a forward conduction. In the previous mode, the voltage is not getting increased, as if there is no current flow. So there is no current flow. This current flow we can say as this area we can say as forward blocking mode. That period we don't have any current flow, and this area we can call it as a forward conduction mode. And we can say the third mode is called a reverse blocking mode, where the supply voltage is getting reversed. That means minus is connected to the anode, and plus is connected to the cathode, where junction J1 is reverse bias, and the junction J3 is also reverse bias, but whereas junction J2 is forward bias. So that is a statement written here. So in this case also there will be a small leakage current flowing through due to the drift charge carriers. So this is not enough to turn on the SCR. So during reverse blocking mode, there will be a small amount of current called a leakage current. So this due to this current, it is not enough to turn on the SCR. Now, as combined way, we can say so this area we can call it as forward blocking area, and this is called forward conduction area, as mentioned here. As we noted here, we need to understand some important concept here. The first one is called forward break voltage. It is a voltage by which the SCR starts conducting, so that we can call it as a VBO. And also we must know the leakage current and holding current. The definitions for leakage current and holding current we must know. Again, this area is called a reverse blocking mode, where there will be a small amount of leakage current is flowing in terms of milliampere current, microampere current is flowing through this. So that current we can call as reverse leakage current. After some particular voltage, that is called a reverse breakdown voltage, the current starts getting increased very rapidly in terms of microampere. So normally in the reverse biased situation, we don't see for any applications. We will consider only positive bias, that is forward bias cases. In that case, forward conduction mode cases alone we will see many places. And the important terms we must remember is, the first one is called a forward breakover voltage. It is a minimum voltage required to start the conduction of a SCR, that is called a forward breakover voltage. Here it is mentioned as a VBO. And the second one is called holding current, as mentioned here. This terminal, it is called the holding current. It is the smallest amount of current under which the anode current has to enter into the off state. So when the current is falling below the holding current, the SCR becomes off. That means the SCR don't conduct. Only when it is above the holding current, that time only the SCR starts conducting. So that means it is the smallest amount of current under which the anode current has to drop to enter into the off state. That means when it reaches below the holding current, that becomes off. And the second one is called the latching current. It is a minimum amount of anode current. Above the current only the SCR is on. So this current is called a latching current. It is a minimum value of current. Above the value only the SCR getting on. Above the value only the SCR getting on. That is called latching current. So we must know the three terms of forward breakover voltage, holding current and latching current. And also we must know, so in the if I keep on increasing the supply voltage beyond the breakover voltage, that time the SCR is getting on. But when we have the gate terminal, gate supply, this terminal is called the gate terminal. For this gate terminal, when we give the keep on increasing this voltage or current to this terminal, so that time also the SCR is getting turned on. So that is called that technique is called we can call it as a gate triggering method. Gate triggering method. So that we will see later. So that so this technique we will see as a separate topic called a triggering or turn on circuit of SCR. Thank you.